Now.
Good afternoon, Chairman Goodall and Chairman Duchesne, and distinguished members of the Natural Resources Committee. My name is Maggie Shannon. I reside in Belgrade, and I'm the Executive Director of the Maine Congress of Lake Associations. Maine's statutory and legal framework regarding surface and groundwater is anachronistic, unscientific, and inadequate. The beginning of the distinction between groundwater and surface water law was probably made in the late 1800s by a Utah lawyer who wrote a treatise on irrigation and who believed, and now I'm going to quote from my writing, in keeping with the science of the day in the 19th century, his name was Clesson Kinney, and he believed that there was an inexhaustible supply of water flowing in subterranean or underground watercourses. And on the basis of this mistaken understanding, it was possible, therefore, later, for many states and many individual interests within those states to treat groundwater and surface water differently. We are among a few states with the absolute dominion rule. You will hear later that our absolute dominion rule has been modified sufficiently by reasonable use standards. It shows you the water cycle. You learned about that in 5th grade. It shows that water is a continuum, that groundwater and surface water are one. There is no distinction except for where they are physically. The water cycle is the way that Earth's supply of water gets renewed. We have the same amount of water today, pretty much, that we did when Earth's water was formed billions of years ago out of the elements that outgassed from the Earth's crust. It has stayed constant. It doesn't disappear unless something drastic happens to our atmosphere. That supply is really interesting. The scientists tell us that, they have a budget for it. We're the water planet. Theoretically, we have as much as we'll ever need. 97.5% of Earth's water is salt. 1.8 is currently locked up in ice. 0.635, or just let's say 0.6% is valuable water in the ground. And 0.01% is in lakes, reservoirs, streams. Groundwater is extremely valuable. It's usually pure. We don't think of water as being scarce because we get over 40 inches a year, and recently we've had more than that. We've had somewhere around 60. And on this graph, it shows you how much water goes into the ground. That's the recharged water. That's what goes into our 300 unconfined aquifers. Because of an accident of geography, we have all this wonderful gravel. We have tons of rain. We have unconfined aquifers. They aren't locked under bedrock like the too sad Oglala aquifer in the high plains, which doesn't get replenished. We may not think, being Mainers, that there is a water problem, but guess what? 30 countries, some of them are pretty big. India, China are among them. 30 countries have water scarcities today. The United States has many areas of scarcity, but one of them is the Atlantic coast. Boston, did you know, has been importing water from jurisdictions outside its boundaries since 1795. There's a river near Boston, the Ipswich River, in 1968 and in 1999. The difference is folks are canoeing on a perfectly beautiful setting in one, and you see the dead fish in the dry river in another. This is from the needs of the population of the Boston area, not just the city, but the growing suburbs. And Kittery is 66 miles from Boston. World water consumption doubles every 20 years. The United States National Intelligence Council reports that water will become the world's chief resource issue by 2016. But maybe if you looked at it on the ground, where the local conflicts occur, where the pumping occurs, you would come to the conclusion that there might be not enough groundwater in one certain aquifer or aquifer system to replenish the wetlands on which wildlife depends. When water is pumped from a location, from a nice, loose, uncompacted, unconfined aquifer, like the ones that we have, what results is called scientifically a cone of depression. So that areas close to the well, what happens is that the water table in the aquifer is drawn down. And that's why I try to make the distinction between the local effect and the overall huge recharge figures. We don't really have adequate data to know what the effect of groundwater pumping on one aquifer over a long period of time is going to be. The United States Geological Survey says you need to have long-term data, 5 to 10-year data, to know. A drawdown of a surface water may not be obvious right away. It may be incremental. It will be incremental. And so if you don't have long-term data, then it's very difficult to assess the immediate and long-term effect. Without the theoretical, the legal, the principle framework that says groundwater is in the public domain, that is, it's in public trust, as our surface waters are, then what we have are a series of discussions about local effects between individuals and the corporations withdrawing the water. You have discussions from watershed to watershed, town to town. And I don't think we have adequate protections. Now, when I attended the committee that the stakeholders process that this committee set up after the last legislature, Jane Eberly introduced a bill for the department, I think it was called the Governor's Bill to harmonize the policy, Maine's water policy between surface and groundwater. Obviously, this state has danced around the hot potato of the difference between surface and groundwater for over 20 years. And that's what's going on here. And I think when we're concerned about people's property rights, private rights, we have to be aware that that's in the background of the discussions that we're having about the adequacy of water. Some may protest that restricting new pumping violates the takings clause of the United States Constitution, which prohibits the government from taking private property for a public purpose. However, courts in many states have concluded that the property right is a right of use. Until the water is used, there is no water right. I learned quite a lot of things in the aquifer sustainability presentation at the Northeast Geological meeting a week ago. One of the water supply experts in Maine, in referring to the protections of drinking water supplies, referring, I presume, to both surface and groundwater, described the system as a lumpy old tire, a lumpy old well-patched tire. That's what we have to protect our groundwaters from the world's thirst. I just thought you might like to think about this drawing in front of you with a large straw inserted in it. And what are the people of Maine going to get out of it? And what effects are we going to be facing on our wetlands and other surface waters? I wanted to draw attention to one other thing on this map. It says that there are 30,000. There aren't 30,000 lakes and ponds. I thought it must have been a typo, so I wrote to the person who made the presentation in which this was introduced, and I got an email back from the Maine Geological Survey saying, according to their water polygons, there are 30,000 lakes and ponds. I don't think that the DEP or IF&W would agree with that, and COLA doesn't. So you gotta, even from scientists, this is my last point, you gotta question the data. We don't have enough data. We don't have enough stream gauges in Maine. They are expensive. We don't have enough stream gauges to really know we have the data to say yes, no, or maybe. And when you're hearing testimony, I think you ought to wonder, I think you ought to ask, how good is the data and who's paying for it?